Hello students. Today's topic is chemical kinetics. Chemical kinetics. What does it mean? Actually, all the chemical reactions proceed in certain manner in which we can say either they are fast or slow or moderately taking place. So, chemical kinetic is the branch of chemistry which deals with the study of reaction rates and their mechanisms. How fast any reaction is going, how slow it is. This is shown by chemical kinetics. Actually, we are going to read about rate of a chemical reaction. So we have around us very fast reactions like photography, in which chemicals are used. Certain cameras take pictures, and due to the light, a chemical reaction takes place on the surface of photofilm. And we have explosives, which are very fast to react, and we have corrosion. We have seen corrosion, which is a very slow reaction. So they are all different type of reactions around us. So we are going to learn about those reactions. So what is rate of a reaction? Let's see. Rate of a chemical reaction. It means how fast it is going. Now we should have something to compare the speed of chemical reactions. Just like we have a pH value or any other type of scale. In case of rate of reaction, we have to implement certain type of scales, so that we can measure the rate of a reaction. So how the rate of a reaction is measured? Let's understand the basic concept. We have reactants getting converted into products. So the speed by which these reactants are converted into products, or the speed by which these products are formed, is the rate of a chemical reaction. So we have to use time to compare how fast a chemical reaction going on. So how these chemical reactions are going on, let's understand what factors may be influencing. Consider these two type of particles. These balls are representing two atoms. They are moving in space. Until and unless they are oriented in certain manner, they cannot form a single product. So this is the requirement of a chemical reaction. If they are oriented to some other angle, if they do not possess certain amount of energy, so reaction is not going to take place. And if they are oriented properly, they will perform the chemical change. So this is how chemical reactions takes place. Now for this reaction to take place, the rate of these reactions depend upon how fast these reactants are consumed or how fast these products are formed. Now reactants are consumed when the reaction is proceeding. The concentration of reactants is decreasing, whereas the concentration of products is increasing with the reaction. Okay, so let's consider this reaction once again in another form. Okay, 1 mole of reactant is converted into 1 mole of product. So in case of concentration, we have to represent these chemicals according to the concentration term. So the initial concentration of R is R1. This is initial concentration, and final concentration, let's take it R2, and this square bracket is used to assign concentration. Now if a reaction is taking place, we have, in case of reactants, this is how they are represented, and initial concentration of products will be shown as like this, and this for the other part, final concentration of products. If time is changing, then in that case it will be also be represented as well. So for a chemical change to occur, we have these values. Consider change in concentration of reactants. How it is going to change? The concentration of reactants will change with the formation of products, but now we are just using reactants. This is final concentration of reactants, and this is initial concentration of reactants. How the concentration of products is changing? It will be represented like this. The concentration of products will be changing final minus concentration at initial state. And during this time, what will be the change in time? Delta T is equal to, initially time was T1, now it is T2. So it will be taken as like this. So we have to keep in our mind that these square brackets are used to express molar concentration of these chemical species. Okay, now when the reaction is proceeding, it means there is change in concentration. So how this change is going to take place? Reactants concentration is decreasing, so we can write rate of disappearance of reactants R will be equal to how much? It will be represented as negative delta concentration of R with time. Now why this negative is there? Actually their concentration is decreasing, reactants concentration, therefore to make it positive overall we have to put negative sign in front of this value, so that it overall calculation this will become positive. We can see it during numericals. Now this is the rate of disappearance of R, but in case of products it will be written as rate of appearance. They are forming. P. It will be shown as change in concentration of products divided by change in time. So this is how it will be represented in case of products. These two equations are showing average rate of reaction. Average rate of reaction is shown by these two equations. Okay. Now let's see units of rate of a reaction. Units of rate of reaction. Rate is represented as the concentration, concentration upon time. Actually change in concentration upon time. So concentration has unit mole per liter, and for time if we are using second, this is what we are going to place. So the unit will be mole per liter per second. This will be the unit of rate, average rate of chemical reaction. Now let's apply this concept of rate equation into uh, certain other examples. For example, let's start with the formation of water. Hydrogen gas is reacting with oxygen gas to give H2O. H2O, let's take it to be steam, then it will be gas. If it is liquid, then the physical state will be different. Now, in this situation, we have these constituents, but this is not a balanced chemical equation. So in order to balance this equation, let's place 2, okay, and then in that case we have to balance hydrogen by putting 2 over here. Now this is a balanced chemical equation and it is according to the stoichiometry. It is according to the stoichiometry because all the components are present in proper amount. This is how a completely balanced equation would be. So how we are going to represent rate equation? In that case we have to mention these values also. In case of reactants, if we are going to note it down, then rate of reaction will be in case of products. Let's take products first. Will be, what is the product? Water, and this is present, so in that case we are going to use it also. So rate will be, products are formed, it will be 1 by 2. Concentration of what? Change in concentration of H2O on change in time. This is how it is to be represented. Now in case of rate of reaction, in case of reactants, we have 2 reactants over here. We have hydrogen as well as oxygen, so in that case rate will be equal to how much? This is minus 1 by 2. This will be go like this, and then we have change in concentration of hydrogen by change in time, and this will be also equal to change in concentration of oxygen on change in time. This is how it will be represented, taking care of stoichiometry of the reaction. So let's some more examples, then we'll proceed to other section. Let's make some space for the reaction. Let's take an example of reaction taking place between hydrogen and iodine. Breaking down, decomposition of hydrogen iodide. It will be much better to understand. Let's see if it is properly represented or not. You have to take care of these values. Now this is the chemical decomposition of hydrogen iodide forming hydrogen iodine. Let's take note down the rate reaction. Rate will be equal to, in case of this reactant, it will be minus 1 by 2, and then we have delta, change in concentration of hydrogen iodide, divided by delta T, it will be equal to the change in concentration of, these are 2 products, therefore no negative sign will be placed here, concentration of hydrogen upon time, and is also equal to change in concentration of iodine on change in time. So this will be the equation. For a gaseous reaction at constant temperature, concentration is directly proportional to the partial pressure of a species, and hence rate can also be expressed as rate of change in partial pressure of the reactant or the product. So we have to keep in mind in case of gases. Now let's take an example for the calculation of rate of a reaction, average rate of reaction. For this we have a question. I have taken this question from the textbook. From the concentrations of butyl chloride CH4H9Cl at different times given below, calculate the average rate of the reaction. This is the chemical reaction which is involved in this process, and during different intervals of time we have to calculate average rate of reaction. So what equation could be formed for this reaction? Let's solve it and see. So we have this reactant butyl chloride. It can be represented like this: rate of reaction or average rate of reaction is equal to change in concentration of butyl C4H9Cl butyl chloride divided by time taken or change in time. Now we know, because it is a reactant, therefore its concentration will decrease, so we have put negative in front of it. Now let's find average rate of reaction between these two values, between 50 seconds and 100 seconds. It means the reaction has completed 100 seconds, and now we want the average rate of reaction of this reaction, for this reaction between 50 to 100 seconds. For this, let's put the values into proper way. Now change in concentration, this is final and this is initial for this reaction, for a rate between 50 and 100. So we'll put these values like 0.0820, and the initial value is 0.0905. So bracket close, and now it's time to take the value of time. Final time is 100 seconds, and then it started from 50 seconds. This is the initial value we have with us. So this is how these values will be put together. Now after subtracting the value, these two values and these two, we get, let's keep negatives with us, and this value will be minus 0.0085, and the value is 50, 100 minus 50. This is what we are going to have. Now we have to divide 0.0085 by 50. But before that, we have two negative values. It will make together a positive value. So let's make it, write it once again. 0.0085 by 50. Okay, let's make some space for it. So the value is going to become 0.00017, and the unit is mole per liter per second. So this is what we are going to note it down, but it can be turned into scientific notation. For this, let's shift this decimal over here. It will now become 1.7 into 10 raised to the power minus 4 mole per liter per second. This is how these values are calculated. Now let's practice one more. So next we are going to take these two values. We are going to find average rate of reaction for this particular reaction when it has completed 150 seconds. We are going to find it between 100 to 150 seconds. So this is final time, this is initial time, this is final concentration, and this is initial concentration for the same reaction. So let's note it down once again. I'm again writing the formula. Average rate of equation, rate will be negative because it is a reactant, and butyl chloride C4H9Cl. Now this is change in concentration of butyl chloride and divided by change in time. For this reaction, this particular reaction, the values will be again 0.0741. okay, this is the value 0.0741. okay, and this is going to be subtracted next value to be taken is 0.0820. We have these values, so let's change it. Let's put bracket, and then we have time. For this we have 150 minus 100 seconds. So let's come to the another page for calculation. Now the value comes out to be minus, and it is 0.0079 after subtracting, and then we are dividing the value with 50, and this whole value is negative, so this is going to become positive 0.0079 by 50, and when calculated this comes out to be 0. We have 3 zeros and 158, and the unit you all know, mole per liter per second. So this is going to be rewritten again in the scientific notation, in which we have to shift this decimal over here, so it will become 1.58 into 10 raised to the power, how many places we are shifting? 1 2 3 4, so it will become minus 4, and again mole per liter per second. This is the value we are going to obtain. This is the average rate of reaction when it has proceeded from 100 to 150 seconds. Now let's consider one more numerical from the textbook. Now this question says, in a reaction 2A gives products, the concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate the rate during this interval. So in this question we have 10 minutes for time. Before this we were using other unit per second or seconds for time. Now we have to use minutes. So for this particular reaction, if we are going to write average rate equation, how we are going to write it? Let's see. Rate of reaction will be equal to minus delta concentration of A, and then we have divided by time. Now we have 2. What is the difference it is going to make in this equation? This 2 will be placed here as 1 by 2. 2 moles of A giving products, so this is kept here, 1 by 2. This is the equation we are going to solve. Now let's put the values. Decreases from 0.5 mole per liter to this much. This is initial value and this is final value of concentration, change in concentration. So we are putting negative 1 by 2, and then we are putting these values. How much? This will be placed first because this is final, and subtracting it by initial concentration 0.5, and then it took 10 minutes, so let's write 10. This is the simple way it is to be written as, and then we have these values minus 1 by 2 and subtract 0.4 and 0.5, which comes out to be minus 0.1. We have these values and we can rewrite this as these negative will cancel, minus will cancel out, and 2 can be multiplied to this 10. Now it can be rewritten as 0.1 divided by 20. Is it clear? Negatives are cancelled, they become plus, and 2 is multiplied to 10. On calculating further, this is going to become 0.005. Now what will be the unit? We have concentration, mole per liter per minute. This will be the answer for this particular problem.